Hi, this is Dr. John Bergdorf. In this video, we're going to explore the cardinality of sets, also known as the cardinal number of sets. Now, when you hear the word cardinal, a number of things might come to mind. You might think of the beautiful red bird. You might think of the Prince of the Catholic Church that's called a cardinal, but this is using the word in a different way. Let's see what it means. The cardinality or cardinal number of a set is simply the number of elements in that set, the number of elements in that set. This is the symbol we use to represent the cardinal number or the cardinality of a set. N stands for number, so you might just think of this as simply meaning the number of elements in S. Let's look at some examples here and see if we can figure out the cardinal number of each one. So this is a fairly simple example. It just consists of a few numbers. The number of elements in that set is simply 1, 2, 3, 4, 5. The cardinality or the cardinal number or the number of elements in set A is simply 5. If S represents the set of all states in the United States, there's 50 of those, so that cardinal number would be 50. This N looks slightly different from that N. It's just a different font, but again, it's representing cardinal number or the number of elements. The empty set has no elements, so the cardinality or the cardinal number of the empty set is simply 0. The natural numbers, if you remember that symbol represents natural numbers, the numbers you count with, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so forth, that does not come to an end. The set of natural numbers has an infinite cardinality, and so we might, at the elementary level, just simply write an infinity symbol. Actually, if you go higher in mathematics, you discover that there are infinities that are larger than other infinities, and so there are different symbols for different sets of infinity, different infinite numbers rather. So in higher mathematics, we sometimes represent the cardinality of the natural numbers using the Hebrew letter aleph and the little subscript naught. That's read as aleph naught. Okay? Now, we're not going to go into that very much. We're simply going to be talking about either it's a natural number or it's infinite. A finite set is a set whose cardinal number is a natural number. So if the cardinality of a set is 1, 2, 3, 50, 6,000, if the cardinality is a natural number, then we call it a finite set. An infinite set would be, for example, the natural numbers whose cardinality cannot be represented by a natural number. The easy way we get around this is simply to say an infinite set is a set that is not finite. If it's not finite, it's infinite. And yes, those words are pronounced a little bit differently. Which sets are finite and which ones are infinite? The set of Major League Baseball teams. There is a certain number of Major League Baseball teams. I believe it's 30, in fact. So that is finite. The cardinal number is a natural number, so that's a finite set. The set of all people currently living on planet Earth, that's a very, very big number, but it is a finite number. It is a natural number. So the set of all people currently living on Earth is finite. Z you'll remember is the integers. That's an infinite set. So again, because we're not going to get into the various Hebrew letters, that we'll just write as infinity. And the set of all even whole numbers, let's look at that one. The even whole numbers would be 0, 2, 4, 6. And guess what? Although that's not all the whole numbers, that set continues on and on and on and is therefore infinite. And I should say up here, we can just say in words, that set is infinite. Two sets are equivalent if they can be put into a one-to-one correspondence. This has a very close connection to the idea of cardinality. If two sets can be put into a one-to-one correspondence, that simply means that the elements can be matched up. Like in example 3, you can match up 1 to A, 4 to B, 5 to C, 1 to D, and 17 to E. They match up. They pair up. You can put them in a one-to-one correspondence. To say that two sets have the same cardinal number is often just said as they have the same cardinal number if they can be put into a one-to-one correspondence. Can these two sets, D and G, be put into one-to-one correspondence? No. You can pair up the D with the G, the O with the O, the second G with an A, but guess what? There's nothing to pair up with the T. So this was a yes, but this is a no. And here's one that might be surprising, and I want to think about it a little bit. Can the set of natural numbers and the set of whole numbers be put into one-to-one correspondence? And your first thought would be, well, no. The 1 pairs with 1, the 2 pairs with 2, and there's nothing in the set n that pairs to the set 0. Well, guess what? You don't have to pair them that way. You could pair the 1 to the 0, the 2 to the 1, the 3 to the 2, the 4 to the 3, the 5 to the 4, 6 to the 5, and like this. And eventually, here's what happens. It looks like we're out, but the fact of the matter is you keep going. So there's an 11 that can be paired to the 10, a 12 that can be paired to the 11, and so on and so on and so forth. So these can be put into a one-to-one correspondence. And therefore, essentially what we say is that these two numbers have these two sets have the same cardinality. Which means, oddly, that although set W has one more element, they really have the same number of elements. And that will give you something to think about.